So far, we've talked about functions and the scoping rules in R, and you might be wondering why any of this information is at all useful. So, in addition to just writing regular functions for manipulating data or for doing calculations, there's one combination of the scoping rules and functions which can be very useful in statistics, and that's for optimization. So there are a few optimization routines in R called Optim, an NLM, and another one called Optimize, and they all require that you pass a function to those functions whose argument is a vector of parameters. So for example, there's going to be some function that you want to minimize or maximize over a range of parameters, and functions like Optim, NLM, and Optimize take that kind of objective function and try to find the minimum or the maximum. So the idea is that, but in statistics, this objective function that we're trying to minimize or maximize, such as like a log likelihood, is going to depend on other things besides just the parameters that you're maximizing over. So in particular, it's going to depend on things like data. And so the question is, well, how do you specify a function that depends on parameters and data and perhaps many, many other things in a clean way, and to write it in a kind of readable programming style, and to make it easier for the user to use these types of functions. And furthermore, and when you're doing these kinds of optimizations, in many cases it's useful to hold certain parameters fixed. And so, for example, fix a parameter to a certain value, then optimize over the other parameters. So the basic idea with any optimization problem in R is you can create a constructor function which constructs the objective function. And then once the objective function the idea is that it would have all of the data and all the other things that it depends on would be kind of included in the defining environment of that function, so that it would kind of carry along those other things like baggage, in its enclosing environment. And so that way you don't have to specify those things every time you call the function. The only thing that you need to specify is the value of the parameter. So for here I've written a constructor function that creates a negative log likelihood. So just as a note, most of the functions in like Optim and NLM and Optimize in R, they all attempt to minimize functions by default. And so when you write your objective functions, if they're designed to be maximized, then you have to kind of take the negative of those functions so that you can minimize them. So another thing is that all the code in this example will be on the website, so you can take a look at the code and try to run it yourself if you want. So here I've got a constructor function that's making a negative log likelihood because I want to minimize the negative log likelihood function. So this is my objective function. It's going to depend on some data, and so that's the argument. So the data is the first argument to this make.neglog-like function. The second argument is a logical vector called fixed, and it determines whether or not I want to fix some of the parameters. So now inside the constructor function, I define another function which takes an argument called p for the parameters, and this is going to be the parameter vector that I want to optimize over. So basically what this function is going to do is going to return the log likelihood for a normal distribution, and I'm going to want to fit my data to this normal distribution. And so we know that a normal distribution has two parameters, a mean, mu, and a standard deviation, sigma. So those are going to be the two parameters that I want to optimize over. And so here I'm just defining the log likelihood and taking the negative of it so that I can minimize it. And then what the constructor function does is it returns the function as the return value. So here I'm going to simulate some normal random variables with mean 1 and standard deviation 2. And then I'm going to make my constructor function. I'm going to call my constructor function with these random variables and create my NLL or negative log likelihood function. So when I print out this function here, you'll see that I see that the body of the function looks like the code for the normal distribution, just like in the constructor function before. But if you look at the environment, you'll see this little tag down here at the bottom that says the environment, and that's the enclosing environment for this function. And so normally, because when you define a function in the global environment, it would just there wouldn't be a special environment tag down here. However, when you define a function inside of another function, then there has to be a pointer to that defining environment so that R can remember kind of what the values of all the free parameters are going to be. And so if you look at this 0x165b1a4, that is a hexadecimal a number which gives the address of where the defining environment is located in memory. So if you look at the body of the NLL function here, you'll see that pretty much everything here is either a local variable or it's a parameter. It comes from the parameter vector p. However, there's one variable here, the data variable, which is not an argument to the function, and it's not a local variable, so it's a free variable. But the data come from the make neg log like function, the constructor function, which were originally passed the data to that. And so the data can be looked up in the environment that the function was defined, and it knows what the data are. You don't have to tell it what the data are. It's already fixed in the function. So if you look at the environment for this negative log likelihood function by calling ls, you'll see that the data variable is there, the fixed variable there, which indicates which parameter should be fixed, and then there's also the params variable there. So those three things are all free variables inside this negative log likelihood function, but they're defined in the defining environment. So now I can call optim on my NLL function. I'm going to pass it some initial values for mu is equal to 0 and sigma is equal to 1, and it'll run, and you'll see that when it optimizes the function, the estimates turn out to be 1.2 for mu and 1.78 for sigma, so pretty close to the truth, remember, which was 1 and 2. Now, I could, if I wanted to, I could fix sigma to be equal to its true value and then just optimize over mu to get the mean. And so when I call so I need to reconstruct my objective function by calling make.neglog_like, and here I set the fixed variable to be false for mu and then 2 for sigma. So I'm setting sigma to be equal to 2 and I'm letting mu be free. So here, now I can just call optimize, because optimize will minimize a function of a single variable only. And because I only have a single variable in this function, I can use optimize. And you can see that it estimates mu to be about 1.21. So slightly different from the previous optimization. I can also fix mu to be equal to 1 and try to optimize over sigma. And in order to do that, I had to construct another function for optimization and call optimize on that. Here I get my estimate of sigma to be about 1.8. If I want, I can plot the likelihood or the log likelihood, and this is very easy to do when I have a function that doesn't depend on a lot of other parameters. So here I'm going to make the negative log likelihood. I'm going to fix mu to be equal to 1, and I want to plot the negative log likelihood as a function of sigma. And so I construct my function here in NLL. I construct a sequence of grid values for the x-coordinate, and then I apply my NLL function to all those grid points and create my y variable. So now I can just plot this I can plot the x's and y's and connect the dots using the type equal to L. Similarly, I can plot the negative log likelihood as a function of the mean by fixing sigma to equal to 2 and letting mu vary. And similarly, I create another grid of points, another set of grid points, and I evaluate the NLL function on those grid points, and I make a plot. So the nice thing about lexical scoping in R is that if you're doing minimization or optimization of some sort, you can build these objective functions which contain all the necessary data and all the other kind of bells and whistles that are required to evaluate that function into the enclosing environment of the function, so that when you call the objective function, you don't need to specify the data and all those other things every single time. They're kind of built into the environment, and they will be automatically looked up in the right place. So you don't have to carry around these long argument lists in order to evaluate the function every single time. So this can be very useful for interactive work and for exploratory work, like, for example, making these plots. So the code for these types of functions can be very simple, and kind of clean, because you don't have to carry around these long argument lists. So just for reference, the main reference for this type of the lexical scoping rules in R is the paper in the Journal of Computational and Graphical Statistics called Lexical Scope and Statistical Computing, and Robert Gentleman and Rossi Haka, who created R, have some very nice examples in this article.